looking at number 4, just need to make sure it's 4. Sorry, yes, 4. Then we'll do 6. Then we'll do 7 of 1.5, page 39. Okay, number 4. 2 go-karts, A and B, race each other around a 1-kilometer track. Go-kart A travels at a constant speed. Go-kart B accelerates uniformly from rest at a rate. Okay, which go-kart wins the race and by how much time? Okay. Okay, so does it matter that the track is round? It makes absolutely no difference. Okay, so, and there's not really a direction in this one. It's just a the end of the race, basically. Okay, so the track is basically 1 kilometer long. Okay, that's a track. It's 1.0 kilometer long. So go-kart A travels at 20 meters per second. So that means that that's the go-kart A. It's going in circles, right? So it's just keeping on going, basically at the same speed as it starts here. So it's a velocity that's constant. So for kart A, the graph that we care for is just looking like that. Sorry, this is time. And it's a velocity, it's constant, and it's 20 meters per second. Okay, I won't write meters per second here. So let's just reflect. So that means that this kart's acceleration, you have to be able to see that, guys. The acceleration graph of this guy is just another color. It's just 0. So it's just 0. Okay, this is really not fancy, right? And why is that? Because you go this way, that's the slope. Right? So if you take the slope at any 2 points on this, right, your delta y is 0. Your delta y equals 0 for any 2 points you pick, because the y value remains at 20, right? So this is why it just remains. Okay. Go back somewhere here, doesn't matter. Okay. All right. And the position graph would just look like a straight line up, right? Going back 1 step, right? Okay. So first up, we need to find how much time kart A takes to cover 1 kilometer. That's pretty simple. We know it's going at 20 meters per second, right? So basically 20 meters, how many times is that going to take to travel 1 kilometer? So you just convert, basically. Just thinking. I got 20 meters per second. And so I'm going to divide. I'm so sorry. So I'm going to delete this. So 1 kilometer is 1,000 meters. And then if I divide by, this is just going to be a bit of math here, by 20 meters per second. This is the same as saying, I'm still learning to use this, so I apologize. This is the same as, I'm sure you remember that, as flipping this fraction here. So I'm going to say 1 second, right? Because there's a 1 hidden here, right? Over 20 meters. So if I divide by a fraction, I can multiply by the flipped version, right? It's just a general algebra trick. Now look what's going to happen. This is exactly what we want. The meters cancel. So it's simply 1000 divided by 20 will give us the amount of time. What is that? So it's 100 divided in 2. So that's going to be 50 seconds. Okay, so cart A takes 50 seconds to get to the end, to make a full circle, to get to the end of 1 kilometer. Okay, very good. Now the tricky one will be the next one. Just move this up. Okay, 1,000 meters to cover, but now this cart accelerates. So cart B, the acceleration, it accelerates uniformly. So it's a straight line. It accelerates at 0.3 periodic meters per second square. So what we want to know is how much time does it take for this cart to travel 1,000 meters? Now we have a couple of issues, right? We don't know time, right? And so we're going to have to be doing a bit of fancy math here. So this is what I've been waiting to show you guys. So this is the first time I'll actually do it with you guys. My trick for not having to use the ugly set of equations we've been shown in the book. We have to think through our graphs, and it's actually really, really straightforward, but it just needs, you just need a bit of gymnastic. So you do realize that we are effectively trying to get to this y value. You agree with me, right? Because the question asks how much time, basically, will it take to travel 1,000 meters? So here, I'll put, now this is in meters per second, so I'll put it in 1,000 meters. So this is 1,000 meters, right? We want to know how much time will it take this cart B to travel 1,000 meters. We're still looking for the same t. This is the same thing. So I apologize, my lines are not exactly in straight line. They should in a perfect world. Okay, so what are we going to do with this? What we're going to do, we're going to use the exact same principles we've learned together, is that to go backwards, use the area. It's a little trick when you look at your y value here. Okay, so just watch this. This is really cool stuff. Okay, we know that this cart, we don't know the time, right? Because we don't know the time for this one. This is the question. It's we're asked, so how long will this cart take, right? So we don't know this time, so I don't need to call it another t, like a tf or something. I'll just leave it at t, because we're just working on this cart B. So I need the area to go and find my y value here of my velocity at my time t. So, this is not It's so challenging to draw on this. Okay. Now, some of you are already looking, okay, if I had a number, I could find the area, but now I have a variable. Okay, that's easy. You just say that the area for this here, right? Area, you just say that it's equal to 0.3 periodic times t. That's totally legal. You're fine. And here's what's going to be really interesting is that what we just wrote here as a definition of our area for here, you're going to put it as the y value here. So look what happens. This is going to be 0.3 periodic t. Now you're looking at me, really, can I do this? Just watch what's going to happen next. What's happening next is that we know that this here, that to go from the graph of acceleration to the graph of velocity, that I use the area under my graph, under my function. I should be more precise. Well, we know that if this is an x, I don't like actually an x because it's actually constant, but it's a constant times a c0, right? So it's a power 0. We know that if I go backwards, now I'm going to integrate, right? Now I'm going to add an exponent to this. So this is going to be of the shape. Now it's starting at 0, 0. We know that, right? So it goes straight here to 0, 0. I don't need that. You guys can understand that. Okay. So to go from this one to this one, right? I'm going to have to do the exact same, find the area. So this is what we're going to do. Right. Let's go slashes this way. Right. But now, here's what happens. Is that I know the y value that I'm supposed to get here. So that's very neat because I can write it down as an algebra problem that I need to solve. So I'm going to write 1,000. We could use the units here. Let's try without it. It's just I tried with the units and it played tricks on me. So I'll try without my units here. And then I find the area of this here. So that's pretty easy, right? It's going to be t times this, but then it's a triangle, so I'm going to divide by 2. So this is going to get me 0.3 periodic times t, but t times t gives me times square. And this is going to be over 2. Isn't that phenomenal? I find that I find it really cool personally. You can do that kind of math just following your graphs. No need to remember those ugly formula of that book. Useless stuff, okay? Just use your graphs well, and you'll be able to go backwards, forward as much as you want. Okay, so if we just solve this, we'll be able to find our t. So let's do a bit of algebra. You're going to shoot the 2 here, and you're going to shoot all the component, the 0.3 periodic, you're going to shoot it under. So you're going to get 2,000 over 0.3 periodic equals t square, and then t square. Do I have more space? I do. Beautiful. So I'm just going to flip both sides here, if you don't mind, just to reorganize. So then I can rewrite this t equals the 2,000 0.3 periodic, but square of the whole thing. That should be lower here, sorry. Okay, square root of the whole thing. That's beautiful. Let's do that. Just calculator. So, square root of this thing, okay, of 2,000 divided. So that's 1/3 basically. Divide and 1 divided 3. Okay. Here, answer gives me 25 seconds. Now let's look at our significant digits. Kilometers were written 1.0, and in my acceleration I had 4 significant digits. So I'm just going to use the 2 significant digits from the 1.0. So if I round this, this is going to give me 26 seconds. If I round everything. Let's compare. How much? 50 seconds. So I'm much faster reaching the end. How much faster am I game winning? 50 minus 26, so that's 24. Okay, so that's like twice as fast, basically. So that was a good win. Let's just compare the book to see if we're on the right track. Number 4. He wins by 27 seconds. But it says cart A. Just look at this. I hate when mistakes happen. So let's try to find it together. This is really worthwhile for you guys to look at this. I'm not ashamed of, I do make mistakes. Where is the mistake? Okay, is this thing right first? Am I making a mistake on this? 1 kilometer, 1,000 meters. I'm going at 20 meters per second. I divide. This is looking good. 100 divided into it is 50. So that means the other car accelerating would need to travel, take 77 seconds. Okay, let's just review our numbers. This was 0.3. This is time. T times 0.3 is my area. T times this gives me this. Then I divide by 2. That looks okay to me. What did I do? Divide by 0.3. Is it my calculator? Is it just my calculation? Let me get a real math calculator. have another one on my phone. Give me 1 sec. I'm starting to suspect that it's just my calculations here. My math. Square root of, I did a funny trick there. I divided by 1/3. Is that what went wrong? 2000 divided by 0.333. Oh, this is, okay, that's pretty stupid. That was just my calculator. So it does give 77 seconds. Okay, so sorry, still trying to draw on the mouse pad. Yeah, so it's my fault. This doesn't give 26, it gives 77. Okay, so everything was right. It's just my calculating at the end. Okay, beautiful. So we've learned that you have to be careful using your calculator. We knew that. Okay, I'll post next ones in a few seconds. Just have to save that.